Hi, my name is Ed Goad, and I'm an instructor at Green River College. In this video, we're going to talk about how we can configure a couple of different ways for configuring default routes on Cisco routers. Now, before we talk about how, let's talk about why. Why do we need to configure a default route? Normally, when you have a desktop or a server of some sort, such as this PC over here on the left-hand side, you will configure a default route. And what that means is by default, this PC knows about everything that is on this network right here. And it doesn't need any routes whatsoever. It doesn't need any direction to get from its local location to somebody else who's on the same network. However, if it wants to reach somebody on the different network, then it needs a default route, in this case, that tells it, use the router right there for anything I don't already know about. Sometimes this is referred to as the gateway of last resort. If I don't know how to get somewhere, then go over there as the last option. So that's a default route from a PC's point of view. When you talk about a default route from a router's point of view, this router knows about its directly connected networks. So it knows about this network over here, and it knows about this network over here. However, this other network that's on the far right-hand side, it doesn't know about. Therefore, for the router on the left to be able to reach the network on the right, it needs a default route that tells it to go over to the other router. Likewise, the router on the right knows nothing about the network on the left, and therefore it also needs a default route to send traffic back. So default routes can help us communicate the traffic back and forth. Frequently, you'll see this in the scenario of a ISP or an internet service provider. Your company or your home will have a default route up to the ISP. From there, getting out to the internet is then the ISP's job. With default routes, there's two specific ways to be able to do this. The most common is to use a next hop IP address. In Cisco, you normally do this by typing IP route, the destination IP or the network address that you want it to go to, the mask that goes along with that destination network, and then the next hop or the IP address of the next place to go. In the example we just looked at, the router on the left being route 000 and a mask of 000. This means everything I don't already know about, everything that I haven't otherwise specified. If I don't know anything else, then go ahead and send to the IP address of 172.16.1.2, which is the router on the right. Conversely, the router on the right says, hey, for everything I don't already know about, 0000, mask of 0000, send to this IP address, 172.16.1.1. Let's look at this in production. Here we have a packet tracer of the network that we just described. I'm going to confirm that routing is not working by logging into PC0 here. And on the command prompt, I'm going to try to ping PC1. So ping 192.168.1.10. When I ping this, I get a reply back from 10.0.0.1, which just happens to be my router. And my router is telling me destination host unreachable. Or, in layman's terms, I don't know how to get there. So the PC is getting to the router, but the router doesn't know where to take it from there. So let's configure our next hop IP. On router 0, I'll go into CLI. We'll go into enable and configure mode. And then I will specify my IP route 0000, mask of 0000, and the next hop IP 172.16.1.2. At this point, the router 0 on the left-hand side will now send all unknown traffic or undestined traffic or any traffic that it doesn't know what else to do with. It will send it to router 1. Let's go ahead and do the same thing on router 1. IP route 00000000 and 172.16.1.1. And so now the second router, if it doesn't know what to do with traffic, we'll send it back to router 1. At this point, our routing should be fully functional. If I go back to PC0 and back to my command prompt, I can now go ahead and start the ping. And the first one may time out due to ARP lookups. However, after that, it should begin to come through. And there we have it. So that is setting up our default routing using our next hop IPs. The other option, which is useful when working with serial interfaces, is to use an interface address. In this case, the syntax looks very, very similar. However, instead of specifying an IP address, we specify the interface, next hop interface. And we see an example right down here. So we start again with IP route 0000, mask of 0000, and then the serial interface that I want to go out of. We can see this by doing that on our router right here. If I hover over router 0, it will show me all the interfaces I have. And I can see I have serial 010 with the IP address. If I look at my other router, I will see over here it is also interface serial 010. Ultimately, this means I have the same configuration on both routers. Let's check that out. I've gone ahead and removed my static next hop address, and instead I'm going to replace it with IP route 0000, and then serial 010. And it gives me a warning and says, hey, if this is not a point-to-point interface, this may impact your performance. So if there's more than one device on the other end there, we may have some problems. Because this is a serial connection, there is only one location on the other end. On the other router, I can go ahead and do the same configuration. And I get the same warning. When that's complete, I go back to my network devices and I can retry my pings, and I will see that it is now working. There you have it, a couple of examples of configuring static routes in two different ways. One using a next hop IP address, the second using a default interface.